Namaste. So this is Balaraju, Subject Matter Specialist, Plant Protection, Krishi Vigyan Kendra, Yagantipalle, Kurnool District, Andhra Pradesh. Today I am going to discuss about ecological management of pests and diseases. So we all know that today's agriculture is highly dependent on external chemical inputs, and farmers are relentlessly using these inputs for production of all kinds of crops in their fields. So whether they are for the fertilizers or they are for the disease or pest management, they are using only and only these chemical inputs. Because of all chemicals only, and they are not at all using any other methodologies or other tools for the effective crop growing or pest or disease management. So the natural habitat, so that is the soil, so which has to give support to the life on the entire earth, is getting spoiled. And because of the chemicalized agriculture for the past few decades, so the health of the soil has been deteriorated very immensely. And now we are going to such a state wherein we cannot repair the soil to its normalcy. That day is not far. From highly chemical dependent agriculture and chemical dependent pest and disease management to, we have to move to a sustainable method or sustainable system wherein we will get more efficient management of these pests and diseases. So one such tested and being employed methodology is ecological pest and disease management. So this is nothing but employing pest and disease management strategies in the field based on the knowledge of their interrelations with the different components of their agro ecosystem where they are. So the objective of this topic is to understand the pests and diseases at first hand, and then to know the relationship they have got with the other components of the ecosystem. And by knowing that, we should devise strategies which will work better based on the ecological principles. So this is our objective of this particular topic. So as I said, today's agriculture is highly dependent on different synthetic inputs or ready-made inputs. So if you want to list them, farmers are using improved seed varieties and hybrids for the sake of better yields, and then to get the complete potential or maximum potential out of the seeds, they are using chemical fertilizers to the maximum. So when they are using these two things, the thirst is more and they require a lot of irrigation. To do all these things, they are using machines in most of the operations, but they also take these crops throughout the year repeatedly, one after the other, any time between two crops, and they are utilizing the soil for the entire year. So they are intensive in their cropping pattern. So all these activities they are taking up, targeting maximizing the production out of that activity. So in this process, they are indiscriminately using these chemical pesticides to ward off any unwanted biotic pressure like a pest or disease or a weed that comes to spoil his intention. But this is not giving the desired results fully. So this is being noticed by all the farmers of the country, and today each and every citizen of the country, or each and every farmer and farming community, and the people working for agriculture and the scientists working in agriculture, they know pretty well that 100% chemical farming is not going to give the desired results. Even it was said very early in the history by Dr. M.S. Swaminathan in 1968 itself. He said that intensive cultivation of land without conservation of soil fertility and soil structure would lead ultimately to the springing up of deserts, and that is the reality, and that is being witnessed today. So, with all this agriculture, which is mostly based on chemicals, now we have reached such a state where our natural resource base is being depleted, and we are witnessing steep fall in groundwater tables wherever this agriculture is intensely practiced. And now the cost of inputs have been at rise from year to year, and this is leading to increasing cost of cultivation. And as they are not applying any organics or any locally available resources apart from these chemicals, so the health of soil has been deteriorated very heavily. And the intention of these chemicals is mostly to ward off the pests and diseases in the field. But against this intention of the farmer, the pests are developing resistance towards these insecticides and fungicides that are being employed by the farmer. So this again is becoming a threat for the successful production. All these are adding to the cost of cultivation by the farmer, so by which he is getting into the debts, and which is leading to lot of misery, and sometimes even farmers are committing suicide, which is being witnessed recent times. Apart from this, the chemicalized agriculture has resulted in loss of biodiversity, which is much needed for striking a balance between good and bad. And now we are all witnessing chemical runoff of these chemicals in the water bodies, and they are reaching the rivers and streams, and that water is even used for domestic purposes, which is giving lot of ill health to the consumers. And the products so produced using a lot of chemicals is being consumed by human population, which is leading to lot of health issues in us. So given this kind of ill effects by the chemicalized farming, now we are in crossroads how to get rid of this kind of situation, or how to improve our quality in the food. So this thinking has led to many thoughts by the think tank, as well as by the progressive farmers, and as well as the scientific community. And they have come up with different models or different approaches which are alternate to this kind of chemical farming. So they are like low external input farming, where the inputs purchased from outside were reduced, and mostly the on-farm and local available inputs were integrated into the farming. One more thing is a sustainable agriculture. So some people were thinking that we make agriculture sustainable, so that in future also agriculture can be a dependable occupation. So with this intention, they have integrated whatever the local resources are there with them, they have integrated, and they have made use of them, along with the sparing uses of chemical outputs which are purchased from the market. And recently we are hearing one more concept, that is conservation agriculture, wherein lot of resources which we put in for agricultural production are to be conserved, or are to be used very preciously or precariously, so that negative impacts on the environment will be reduced. So this is conservation agriculture. Here we are mostly focusing on reducing the tillage operations, and then conserving the soil moisture. So such kind of things are being used in this kind of agriculture. And now the buzzword is organic farming. So wherein chemical inputs are stopped, and instead of chemicals, organically produced materials and locally available organic manures and organic resources, concoctions, botanicals, such kind of inputs are being used for successful crop production, and which is being certified by notified agencies as organic produce or organically produced products. And another one is biodynamic farming, wherein some kind of biodynamic cultures have been utilized for growing the crops instead of chemicals. And then is permaculture. This is nothing but permanent agriculture. So here the efforts are to see that in a piece of agricultural land, whatever the produce and byproducts are produced, they are once again plowed back or once again reused in the same piece of land, and the agriculture will be continued without any external input. So here many systems have been used to achieve this objective. Then nowadays natural farming is being focused in recent times. So now natural farming is being talked of by every farmer or every official who is related to agriculture in the country. So we want to do the farming as naturally as possible, or as close or as mimicking the nature. Means you are going back to your ancient times. So we should do agriculture in the same manner as our ancestors have done farming without using any synthetic inputs. So that kind of natural farming is being thought of these days. And some people have named it as even ecological farming. So they want to take care of all ecological issues, and they want to have good agricultural practices, so which are not harming the ecosystem around the farm. So in this context, ecological pest management, if you want to understand, first we should know what a pest is. So if you want to describe a pest is any living organism that is capable of causing some kind of disturbance or ailment or suffering or damage to the cultivated crops or cultivated plants. Either physically they can do the damage, or some of the physiological activities of the plant or system may be damaged. So then we call it as a pest. So examples are insect pests and diseases that we regularly see in our cultivated crops. So then what is pest management? So we know that these kind of living things are causing a lot of damage or ailments to the crop we are going to take up. So to ward them off from doing the damage, we are employing different tactics or methods in this crop production to keep them away from feeding on the crop, or to make their damage to a minimal level. So we are employing different methodologies, and we are employing different chemicals, and we are employing different cultural practices, and we are employing some mechanical devices to get the result. So that is called pest management. So examples are, so we are treating the seeds before taking up sowing, so that an unwanted disease or any suffering should not be there in the season. So with that intention, we are taking up seed treatment both for diseases as well as for some kind of pests. We do this seed treatment, and this is being recommended by even scientific community and universities. And then as a part of IPM program, we do take up this bird perches, installation of bird perches, and usage of pheromone traps, sticky traps, delta traps, and even some sprayings like neem oil spray and choosily or intentionally or unintentionally we are going for chemical pesticide sprays also, aiming that the pest or disease will be cleared by use of these chemicals. So this is all comes under pest management that generally we do practice in this modern agriculture. Then what is meant by ecological pest management? So we have put a word ecological. So here ecological means it's nothing but, so the pests in its environment will have some interrelations and interactions with other components of this its ecosystem, like soil, it will have some kind of interaction with the climate that is surrounding the pest, it have some kind of interaction and influence, and the kind of tree, the kind of plant it is harboring, it will have some kind of interaction, and the temperature or the water that is surrounding the pest will have some influence on its performance. Likewise, so it has got so many kinds of interrelations with the components which are there all around its ecosystem. So understanding all these interrelations, components individually as well as the interrelations with these pests and diseases, we will devise different strategies to be applied in the field with very much care and good understanding of these pests and their interrelation with the other constituents, and employ in the field to keep these pests and diseases under check or in balance with other beings. So if we do this kind of strategic treatment or deployment, then we call it as a ecological pest management. So what is the main part of this ecological pest management? Here soil health and crop health, these are the two major issues in ecological pest management. Of course, though we are not directly talking about pest management, here the health of soil and health of crop, these two things play a major role in pest management or pest incidents. So we need to understand these two things first. So if these two health issues are solved, then our agro ecosystem health will be perfect, it will be good. So then the pest and disease emergence will be minimum. So this is the understanding. So if you want to know about the soil and also the crop health, so we need to take up some management activities. So this management activities can be of two types. One is above ground management, above ground habitat management. Habitat means all the surrounding areas, all the surrounding things that are there to the crop. So we call them it as habitat, and we have to do proper habitat management. So here in above ground habitat management, we will look for plant diversification and enhancement of beneficial fauna, because diversity and beneficial organisms, these are the two key things that will decide the outbreak of the pest or disease or its suppression. So these two things are stressed even above ground as well as below ground. In below ground habitat management, that is soil, inside the soil, we see biota activation, means the activation of the different kinds of organisms that are there inside the soil. And what are the different kinds of organisms that are there in the soil, that is diversification. So these two things, how healthy the organisms inside the soil are and how different the organisms inside the soil are, these are the two key issues that will have a bearing on soil health. So we have to bring about these needed changes in the having good health of crop as well as the soil, then our pest or disease will be under check. So to attain this, we have different strategies or different needs. So if you see the above ground habitat management, there are few things we have to take care of. So one is crop diversity, another one is crop rotations, another one is cover crops, and breeding for resistance towards pests and diseases. These are the 4 things we have to bear in mind to have a better above ground habitat management. Likewise, if you see the below ground habitat management, we need to reduce the tillage first, and then we should maintain a cover on the soil continuously throughout the year, and then we should add ample amount of organic matter to the soil, and we should see that all the nutrients needed by the crop should be available inside the soil. So these are the 4 issues we should take care of if you want to have a good habitat management inside the soil. So if you look at soil, when we call it as healthy, and first of all, what is there in soil? So if you see, soil consists of 4 things in it majorly. One is mineral particles, another one is water, air, and some organic material. These are the 4 major constituents of soil. So the mineral constituents, that is mineral particles, will make about 45% of the total soil, and then water and air each will take a share of 25% of the total, and the remaining 5% is organic material. If the constitution of soil is exactly in this proportion, you can easily say that that soil is healthy, that is in a healthy soil, perfectly healthy soil. So in that 5% organic matter, if you divide, about 3% should be humus and 1% should be occupied by the roots, both living and dead roots, and 1% should be occupied by the living organisms, various kinds of living beings that are there inside the soil. So then we call it as a healthy soil. So if you see the picture underground the soil, so the soil will have some kind of insects which is roaming here and there, and then some kind of insects which are making burrows like these earthworms, and some kind of microbes, mostly bacteria, fungi, nematodes, actinomycetes, like kind of things. And then even you can see lot of plant roots which may be dead or which may be live. All these constituents will make up the soil below our feet or soil below the field, that is crop field. If you look at the above ground part of the agriculture land, there lot of vegetation, that is different kinds of plants will be there, and there also some kind of insects will be there, macro insects will be there, and micro insects also will be there, and even birds, and even different kinds of creatures like snails, snakes, reptiles, crabs. So all these kinds of things will be there above the ground. So likewise, the soil below is also having some life, and soil above is also having some life. So it is said that if you take a handful of soil from a good ecosystem, it may contain some 9 billion of bacteria, some millions of fungi, some millions of actinomycetes, and some lakhs of protozoans, and some thousands of nematodes. So likewise, so each handful of soil, good soil, will have this many number of life forms in it. But today, if you go and see any cultivated land and you test it for any life inside, hardly you are getting some thousands to some lakhs of bacteria inside, nothing else. So it is more than 10,000 times or 1 lakh times lesser than the desired number. So the soil, good soil or healthy soil, will have 2 to 3 different properties. That is, the biological properties, chemical properties, and physical properties of soil should be good to say it as a healthy soil. So if you look at the physical properties, the soil should have good tilth, the surface structure should be porous and stable, and no subsoil layers should be restricting the root development, and there should be good aeration, good water storage capacity and good drainage. Then we call all the physical properties of soil are good. And if you look at the chemical properties of the soil, the pH of the soil should be near neutral, and there should be optimum content of nutrients. Different nutrients should be in optimal levels, and there should not be any harmful chemical residues inside, and there should be less salts inside the soil. Then we call it as good chemical properties are there in the soil. So if you look at the biological properties, there should be a lot many number of different kinds of organisms inside the soil. That is, biodiversity should be there inside the soil, and plentiful of beneficial organisms should be there, and there should not be much pest pressure. So then we call that biological properties of the soil are good. We say now the soil is totally healthy because all three types of physical, chemical and biological properties are good. So the soil health is dependent on soil structure and the mineral composition, organic carbon inside the soil, and also the microbial load. If you see this picture, a healthy soil will look like this. Here the soil structure is very good. Why? Because the soil particles are grainy in nature with lot of interspaces, so which directly allows water to seep in, water to get in, and also it will hold lot of air inside the soil. And above the surface of the soil is covered with dead vegetation, means leaf litter, everything should be covered on the surface of the soil. Then it will be very healthy because the desired food for the microorganisms inside the soil is provided by the leaf litter on the ground, and it should have high organic matter inside the soil also. So then we call it as a healthy soil. If you see that kind of soil, it should be some darker in color. We look at a degraded soil. So here the soil structure is very weak, means there you won't find any grainy structure. Instead of that, you can have powdery structure, and water infiltration in this is very less because there won't be any soil spores, and water runs off quickly. When you get a rain, so the rain received on the soil will flows off instead of infiltration. You can find lot of flowing water in this kind of soils, and then it is lighter in color when compared to a healthy soil, and it will have low organic matter. That is the reason why it is lighter in color. And then soil surface is covered with a soil crust, a hard pan, so that nothing will enter into the soil. All water that is collected through the rain will flow away from the soil according to the slope. So then if you see the crop health, when a crop is having good physical appearance and when it grows and develops as desired, and when you don't see any nutritional deficiencies, or when you don't find any pest or disease damaging the crop, then we call that the crop is in good health. So for this to happen, there should be continuous supply of nutrients, water and air to the crop. But the fact is that to make nutrients, water and air available continuously to this crop, so this is influenced by the presence and activity of beneficial microbes everywhere. Means microbes should be there in the plant, microbes should be there in the soil, so that all these desired nutrients, water and air are made available. How it will be there? Just look at this picture. So if you see the first picture, the plant, in the process of photosynthesis, it will produce its food by utilizing sun's light and carbon dioxide from air and water vapor in the air. It takes all these three ingredients and it will prepare its food as a carbohydrate. So this carbohydrate, it utilizes for its own growth and development above the ground, its growth and development of its roots, and also some of these carbohydrates it will liberate or it will release through the roots into the soil for attracting different kinds of microbes towards its root system. So, this is the thing the plant will do. So, the sugary substances or carbohydrates so released into the soil will be attracted by the microorganisms that are there inside the soil. So, in response to these sugary substances, these microbes will get attracted and will come closer to the root system. They will utilize these carbohydrates, they will grow in number, and in return they will release some kind of hormones and enzymes, so which are needed by the plant. And some microbes like bacteria get into the system, get into the plant system through the roots, and they will occupy the intercellular spaces of this plant system, both within the root, both in the stem, or even they will reach the leaf lamina. So, the microbes which are there inside the plant system, we call them as endophytes. So, if root system is occupied by these organisms, so we call them as root endophytes, stem endophytes, and this leaf endophytes. So, all these places are occupied by different kinds of microbes. So, this activity should take place in any living being. If microbes are not there in the living system or in the system of any life or any living organism, its functions will not be proper. So, there will be some deficiency in its functions. If the soil is rich in microbial content, it will provide all the nutrition, water and air required by the plant in sufficient quantities. All these microbes enter the plant system and they will make the plant healthy. So, all the organisms that are there living inside the plant system, we call them as a plant microbiome. So, all the living microorganisms that live inside the soil, we call them as soil microbiome. So, if soil microbiome is good, plant microbiome will be good and the plant will be healthy and it will produce good quality food. If such a good quality food is taken by the human beings along with the some of the microorganisms that will enter the food system which are good, so his human body also will have good microbes inside his body and it is called human microbiome. He is taking the food which is produced by a healthy plant. The plant is healthy because the soil microbes are plenty in number and soil is good. So, here the soil microbe, plant microbe will decide how a human microbiome should be. So, if it is not proper, if you see the left side of the picture, if the soil microbiome is not good, that is they are not in sufficient variety and numbers, then the plant will be poor in its growth and it will give very low quality or poor quality food. If the man happens to consume this poor quality food, his system also will be poor and his health will be fragile. He will not be having good health. To have good health of human beings, to have good food, to have good healthy plants. To have good healthy plants, the soil should be healthy. So, soil health is directly proportional to human health. So, this is health of plant is brought about microbes inside the soil. So, everybody knows that plant needs about 18 to 20 kinds of different nutrients for its growth and development. All these nutrients are not being supplied by chemical fertilizers because mostly chemical fertilizers are confined to N, P and K and the rest are mostly macro and micro nutrients, so which are needed by the plant in very smaller amounts. Normally this supply of these micronutrients is taken care by organic matter present inside the soil. So, normally plant which is grown on sufficient organic matter and judicious utilization of chemical fertilizers, you won't see any kind of micronutrient deficiencies in it. But In today's agriculture, we are witnessing a lot of micronutrient deficiencies because any manures, composts or cakes we are not at all utilizing. We don't even use organic manures. At least even 3 years once also, it is very rarely applied by the farmers. So, we are witnessing a lot of micronutrient deficiencies. So, these micronutrients in a natural ecosystem are supplied to the plant roots through the actions of these microbes. So, the microbes will have a lot of beneficial effects on the plant growth. So, the microbes inside the soil detoxify the any toxic chemicals that are there in the soil, and they will support the plant to grow better even under waterlogging conditions, and they will reduce the temperature of the soil so that the plant's roots get grow better, and it will give a strength for the plant to sustain the drought situations also, and it will improve the defense mechanism of the plant to ward off the insect pests and also to resist the pathogens from entering into the plants. And if at all some nutrient limitation is there, if you don't apply any one kind of nutrition also, so because of the activity of these microorganisms, it is the plant is able to even resist the nutritional limitations also. So likewise, if microbes are good numbers are there inside the soil and the plant growth and development will be good, it will have all kind of defense mechanisms working without anybody's intervention. So this is the natural defense mechanism of a plant. So plant produces chemicals that slow the pest feeding. This is in natural ecosystem, this will happen. Plant will produce some kind of chemicals, so which will slow the pest to feed, means it will repel the pest. It will not allow the pest to feed because the chemicals produced by the plant are not relished by the pest. So the eating will be slow. So this will happen if it is grown naturally. And the second one is the plant gives off signals to attract beneficial insects that attack the pests. So it will liberate some kind of chemosenses, so which will be taken by the beneficial insects that are flying around, and they will be attracted to the plant, and then they will fight with the pests. So third one is plant increases extrafloral nectar as food for adult beneficials, means so nectar also it will release and it will supply to the adult beneficial insects as a food, so that more number of beneficials will be attracted towards this plant. So this is all natural defense systems that is exist inside the plant. So another one is induced defense mechanisms. There are two kinds of induced defense mechanisms that exist in nature. One is systemic acquired resistance, another one is induced systemic resistance. So here in first case, systemic acquired resistance means when a pest or disease tries to affect or tries to damage or infect the plant will get a signal that somebody is attacking him, and it will be alerted, all the inside systems will be alerted, and it will release some kind of chemical signals, and all its plant parts will be alerted, and they will get ready by themselves so that they can resist or they can fight against the invading pest or disease pathogen. So this is called systemic acquired resistance. This will happen naturally in the ecosystem. So in second case, that is induced systemic resistance, here with some kind of activity of the microbes that are there inside the soil, mostly these PGPRs, plant growth promoting rhizobacteria, they will stimulate the plant roots and they will cause production of defense hormones inside the root system, which will start the defense mechanisms inside the plant by way of releasing ethylene and jasmonate hormones. So this will improve the defense mechanism or defense capacity of the plant against pest and disease. So this is brought about by the action of microbes inside the soil. So we call it as induced systemic resistance. Normally the Pseudomonas fluorescens that we naturally use as a seed treatment material or seedling dip method, then the plant roots will be invigorated and the defense mechanism will be improved so that the plant can resist any kind of disease that is going to attack the plant. So we can see this in two parts. One is that above ground habitat management and below ground habitat management. So if you look at the above ground habitat management, so we should take up some activities for having this above ground habitat management. One is sowing multiple crops and selecting varieties that are resistant to local pests. So this is one thing. So in addition to having other qualities such as yield and taste, good yield. So based on these characters, we should select the crops and varieties. And then we should use proper plant population with intercropping to help the crops grow better, and they will smother the weeds and provide some protection against the pests. A variety of crops should be mixed and grown in sufficient populations. So the third one is you should plan to plant trap crops here and there in the field. Example, marigold and castor, which will attract a particular pest better than the economic crops. So then is plant biomass trees to borders, which gives biomass for incorporation as well as shelter birds. So some tall growing trees should be planted in the borders of the crop so that the birds will take shelter and they will enter the field and they will prey on the pests. One more concept that is recently emerging in is ecological engineering, wherein we plant a mixture of different flowering plants all around the fields in the strips or on the bunds, so that the flowers will attract the beneficial insects and also they will provide some food and shelter to the insects, which will prey on the insect pests that are there in the field. And then above ground habitat management, push and pull system is also there. It is widely practiced in case of corn, especially in Africa. So wherein low growing legume like desmodium is planted as a repellent plant as an intercrop, which will push the stem borers away from it, and some grasses, fodder grasses are grown all along the field boundaries to attract the adult insects, which also will provide nitrogen and suppress the weeds. So both pushing the insects out and pulling the beneficials in. So these two things will happen this in push pull system. So which will give very good protection against this stem borers, especially in case of corn. So then using cover crops. So after the main crop is over, instead of keeping the land vacant with the residual moisture, we have to some crops like these legumes, which will provide habitat for beneficial insects, and also which will add some nitrogen or organic matter into the soil and reducing erosion because of its presence, and enhance the water infiltration to the soil. And much more ecological services will be done by these cover crops. So you need to have legumes after main crop season. And then you have to use the different crop rotations, which involves plants of different families, and if at all possible include crops such as grass or clover or hay that remain without soil disturbance for a number of years, which will improve the soil condition, especially which will improve the organisms growing inside the soil, because they will not disturb the their relations. So this is an example of crop rotation where non-legume is rotated with legumes, or leaf shedding plants are rotated with non-leaf shedding plants, and green manuring by grain crops, highly fertilizer needed crops with non-fertilizer crops, long duration crops with short duration crops. This is the kind of crop rotation we need to practice. And then intercropping and mixed cropping. So green manuring crops, intercropping crops, mixed cropping crops. So banana and legumes as a mixed crop is the best example, and castor and red gram grown together is also a mixed cropping. And intercrops means very popular intercropping system is in this southern Andhra Pradesh is red gram and groundnut. So for every 7 rows or 8 and 11 rows of groundnut, 1 red gram is grown, row will be there, and groundnut and bajra, red gram and maize, cotton and red gram. These are all the better intercropping systems. And wherever it is possible, it is better to grow biomass plants of legumes before the main crop, and once the plants starts flowering, then it is incorporated in the field where main crop is being taken. So this green manuring, diancha and cowpea can be used. And this is the ecological engineering which I just explained. So all along the borders of the main field, if you plant some flowering plants, it will attract the beneficials, which in turn will keep the pest under check. And this is the cover crops. After main crop, we have to take up cover crops. So it will have a number of good qualities which will suppress the weeds, suppress the nematodes, increase infiltration of the water, reduce the erosion, decrease soil compaction, attract beneficial insects, decrease the nutrient loss, increase soil aggregation, add organic matter, enhance the mycorrhizal numbers. So it will have many beneficial impact on the soil. So if you come to the below ground habitat management, there also lot of things are there, like reduced tillage. So tillage is the main culprit for good quality soil. So you have to reduce the tillage, means you need to till the soil whenever it is exclusively needed. You should not till the soil now and then, just for the sake of keeping the soil clean. Then green and green leaf manures, and then manures of composts of different kinds, oil cakes and residual incorporation. And if at all possible, you need to keep a lot of live or dead mulch on the soil, so that the soil is not directly exposed to the sun. It will not heat up. And cover crops, as we already discussed, and then sheep penning and forage crops or fodder grasses in vacant lands, so that some living roots will be there always inside the soil, which will be feeding the growing microbial population inside the soil. So these are the above and below ground habitat management. This is the proactive management. All these methods will come under proactive management of the pest and disease management. So before the pest or disease occurs, we have to do these things. Whether the pest will be there or may not be there, we have to practice them as a habit. So then we call it as a proactive management, and these two kinds of things falls under this. And when comes to reactive management means when the pest or disease occurs, then we will take up some activities, that is called reactive management. So here in ecological management perspective, it should start with the use of bioagents, and then biostimulants, botanicals and liquid concoctions, biofertilizers and biopesticides likewise. And hardly you can use chemicals, because as a last resort you can use, if at all, if nothing works, then if you can go for chemicals. So when we put all these together holistically, we can see this as a soil and crop management, as a preventive management, post planting management and reactive management. So with the overall goal of optimal crop yields and quality with high positive and low negative environmental effect. So this is the overall management system. So if we summarize, use of local inputs for soil fertility, like crop rotations, mixed cropping, applying manures, cakes, compost, like that. And then you should have crops to cover the soil for the entire 365 days, that is living root system, wherein Navadhanya, PMDS, that is pre-monsoon dry sowing, cover crops and pastures are taken up, or soil disturbance at a minimum level. So no or zero tillage, reduced or minimal tillage should be there, and biostimulants as essential catalysts. So keep on applying Jivamrut, Amrit Jal, waste decomposer, Gokrupa Amrita, Konopajal kind of things to the soil, so that the soil microbes will get needed food continuously, and also they will grow in different varieties because of these different products. And then utilize native seed for intercropping and mixed cropping. Traditional varieties of seeds should be sown as an intercrop or mixed crop, so that they will be conserved and the good qualities of these traditional varieties are felt. And then conservation of moisture and water. So for this, mulching, multi-layer cropping, ridges and furrow method of irrigation should be practiced. And then incorporation of trees onto the farm. So all along the borders, if you incorporate tall growing trees with a lot of vegetation, you can have a lot of biomass that can be utilized as green leaf manure, and trees and bunds for harboring birds, so which can act as natural predators. And then ecological engineering, that is flowering plants in borders as nectar source for beneficial insects and to attract the beneficials. And then bringing animals into the farming. So now the integration of animals is very much needed in the farming, because we largely depend on farmyard manure as a key input in the agriculture. That's why you need to have integrate them. And also sheep and goat and poultry, and their manures are also being used very effectively. So integrating them will give good results. And then more organic debris in the soil. So as far as possible, green manures and green leaf manures should be taken up, and the residues of crops. So after this crop production should be incorporated. They should not be burnt. Now we are witnessing a lot of residues being burnt in the country, especially in Haryana and Punjab, and a lot of this pollution problems are there, and it is raising a lot of concerns. So we need to look at possibilities of these residual incorporation, or utilizing these residues for compost making, or some other thing instead of burning, so that we can avoid the pollution. And then using plant extracts to control pests. So neem seed kernel extract, pangam seed kernel extract, so this can be utilized. Likewise, dasagavya, panchapatra arc. So these kind of preparations, which can be by utilizing the different kinds of plant parts, we can prepare these botanicals, and you can spray when the pest or disease appears. So this can be a better option. And then use of biofertilizers for better nutrition to the crops. Because we know that a lot of chemical fertilizers have been applied to the soil, and except nitrogen, all other nutrients, when we apply to the soil, they will be fixed inside the soil. Nitrogen can be escaped as a gas. So the fixed heavily applied phosphorus and potash can be utilized by making use of these biofertilizers like PSB, KMB, like that. And VAM will provide all sorts of nutrients to the plant. They can bring from faraway places even to the root system. So we have to utilize these things, because unless you apply these biofertilizers or these bioinoculants inside the soil, the normal requirement of the plant cannot be met, because the nutrients are not mobile by themselves. They need to be carried by someone and given to the root system. So that activity is taken up by these living bioinoculants like this azolla, BZ, blue-green algae, rhizobium, azoospermillum, and also you need to apply these biofertilizers. And then use of biopesticides for checking pests and diseases. Trichoderma, Pseudomonas, these are the two biofungicides that can be employed for soil-borne diseases and foliar diseases. And then entomopathogenic fungi and entomopathogenic nematodes, NPVs, Pseudomonas, Bacillus, these are all other biopesticides that can be utilized for pest management, different kinds of pest management. So these are all the organic manures and preparations that can be taken up. Jivamrit, this is the Jivamrit application, and Panchagavya by making use of 5 kinds of products from cow. So this will have number of microbes inside it and a lot of microbial load in it. And when 3% of this Panchagavya is sprayed onto the crop, different crops, the growth and development of crop will be good, and the disease and pest resistance also will be good. Dasagavya, this is prepared by making use of 10 kinds of plants, and this can be sprayed on crop towards management of any invading pest. And these are all other botanical sources by utilizing which we can prepare various botanical extracts. Ajadi Rakta, Pangamia, Jatropha, Annona, Acorus, Curcuma, Cypress, Coleus, garlic. And these are all some liquid preparations for disease management. 3% buttermilk, very sour buttermilk that can be used, and 5% cattle dung and urine, and 5% ageless leaf arc, and 5% wild asimum and 0.15% asafoetida in 5% dung and urine. So these are very easily available in our surroundings, and that can be employed for disease management. At least in our backyards we can try these things, because these will give very good results. They will not allow plants to develop any kind of diseases. And this is biofertilizers. Biofertilizers are carrier based living microorganisms which, when applied to the soil, they will help in nitrogen fixation, mobilization of the fixed phosphorus or potash or kind things. So these are the biofertilizers. Azotobacter, Rhizobium, these are the nitrogen giving biofertilizers, and PSB and mycorrhiza mobilizes phosphorus. These are biopesticides, is a form of pesticide based on microorganisms or natural product. So these are all the examples of biopesticides. This is Verticillium lecani, a very good biopesticide nowadays, which is easily applied for whiteflies, green scales, aphids, mealybugs, all variety of the sucking pests. The only thing is, for growth and development of these Verticillium lacani or any entomopathogenic fungi, there needs some humidity. So it is better we apply them from the month of September up to February. They will work better, because during this period humidity will be there in the air. And in irrigated ecosystem, these biopesticides work better when compared to drylands or rain-fed situations. And then is Bavaria, so which is like a very common biopesticide which can be employed for any kind of pest, whether it is a sucking pest or a leaf eating caterpillar. We can easily employ for both this Bavaria. This metarhizium, this is very good for soil inhabitant pests, especially weevils, beetles and grasshoppers, which will hide inside the soil for a very longer period of time. So in such cases, if you use metarhizium as a soil application along with some manure, so they will be killed. And even metarhizium can be utilized caterpillars also, as an above ground crop also you can spray them to get rid of caterpillars. And these are some biofungicide like trichoderma, so it will be like this. It is helpful for soil-borne disease management, and Pseudomonas is useful for foliar diseases in rice, vegetables and banana. So some plant growth rhizobacteria, as I already discussed, so they will grow better inside the rhizosphere of the any plant system, giving hormones and enzymes for the plant, by which, making use of which, plant will grow better and it will put forth a lot of fresh growth and development. So this is the one of the demonstration we have taken up at our KVK with the application of Pseudomonas and other biofertilizers into the paddy. So we have made a small 10 by 10 field. We kept 2 inches water there, and we taken 1 kg of all these ingredients and we mixed in the water, and we kept all these seedlings roots dipped in the water for about half an hour, and then we have taken for transplantation. This has given very good result, especially they have helped the plant to grow better, and as well as they offered the resistance against blast, blight and even this stem rot. So these are the 2 methods of making this botanical extracts. Seed kernel extracts, overnight soaking and next day filtering and using. And oil sprays, you need to add emulsifier and you dissolve it in water and then shake it well and make up the volume and shake and spray. So at Krishi Vigyan Kendra Yagantipalle, we have been promoting bio-intensive farming for the past 10 or 15 years. So in this connection, we established a bio research center for production and supply of various these bio inoculants at our KVK in 2010. And we have conducted a lot of demonstrations under Biotech Kisan project in chilies, acid lime, Bengal ram, rice and banana, utilizing these bio inoculants. And then use of biofungicides like Pseudomonas, trichoderma, biopesticides like Bavaria, Verticillium and biofertilizers like NPK consortia and zinc bacteria are demonstrated with chili crop as well as rice crop under NORM SCSP scheme and IIR SCSP scheme in 2020-21. So these are all some results. So there is a yield advantage of about 14 to 20%, 14% 20% in different crops like chili, acid lime, Bengal ram and rice when we employ these bio-inoculants. And we are conducting some skill training programs on organic farming, 1 month duration we have conducted, and these trainings are on a regular process. We are conducting organic farming trainings, natural farming, bio-intensive pest management and production and handling of bio-inoculants in collaboration of Agriculture Department, Horticulture and with some of NGOs. And recently, last year, we have conducted about 4 training programs on production and handling of bio-inoculants for about 100 participants from various NGOs across India, so which was sponsored by this NCNF during last year. We have established around 105 bio-resource centers under APDMP project in 105 villages for local production and supply by the farmers themselves. So these are all some pictures of that APDMP cluster villages. Bio-resource centers are there in 5 districts of Andhra Pradesh, that is Chittoor, Kadapa, Kurnool, Anantapur and Prakasham. So we have supplied them with cultures. We taught them how to produce the, mass multiply these cultures at their level, and even we have helped them to apply in the field and convince the farmers. So these are all some photographs of visits and local manufacturing process.